So class, we were working on this problem during class, and it was quite messy. Ran out of space and made a small calculator error, and it just was a little confusing, and I promised you I would redo it again. So this is where we left off. T is the time from the start. We have two models for population A, the city of A, and for the city of B. And we're trying to find out, will these two cities ever catch up to each other? And they will if the equations are ever equal. And so this is the equation down here that we want to solve. So I gave myself a new screen, a big slate, so that we can solve that here. Alright, I've transferred the equation over here, and I want to start solving for t by itself. Now there is more than one way to solve this, but the approach that I've been telling you is to isolate your logs and divide that on both sides. Okay, it simplifies after we divide into this equation. 250,000 divided by 50,000 gives us 5. Now, how are we going to solve for t when we have t as exponents and there's two of them? Now, there is more than one method. We talked about this in class, but just to keep things consistently, I'm going to keep solving it the same way. And if you have exponentials, it's good to take a log on both sides. So I've written down the log on both sides, and then I'm going to take the black equation from before and make it the input into both of these equations, or in both of these. Okay, so I'm doing the log on both sides of the equations, and I'm looking at what I can do to simplify these equations. Now clearly on the left side, I can use rule number 1 right here. And so I'm going to take advantage of that and multiply t times the log of 1.035. The question is, can I use rule 1 right here? Got this exponent. And the answer is no on rule 1 because it has a multiply in this problem. That t power doesn't apply to the 5, and I have to have a single base inside my log to use rule 1, so I can't use rule 1. However, I can use rule 2. Rule 2 applies because of the multiplication. And so I'm going to take this log and split it into addition. I have a log with a multiply inside, and now I'm going to make it a adding of two logs. Alright, so rule 2 worked here, but now I can use rule 1 here on this one, so we can keep simplifying. And I'm going to pull that t out front. Okay, now I have made things a lot better because t's are no longer exponents. T's happen to be multiplications, and so I can isolate t, but I'm going to have to subtract this on both sides. And with subtracting on both sides, now I'm going to begin to try and simplify things here. So I'm going to bring all of this down. They're not like terms, so I have one long expression here. Alright, so subtracting on both sides. Next, I've got two factors of t on the left side. And so I'm going to factor out the t, and that's going to make things very easy to solve at that point. Okay, so it's long, there's a lot of writing, and I'm saving time just by writing it off screen here, off the recording here, but we've got this equation and we're really close. All we need to do now is divide that giant expression to get t by itself. So I'm going to divide this whole thing on both sides. Okay, with this division on both sides, I can cancel this whole group. The whole group cancels out. And that's really my final result. T equals the log of 5 divided by the log of 1.035 minus the log of 1.016. All right, now this is the solution to this equation way up at the beginning. And it's when will the cities have the same, will they ever meet in their population? And they will meet at this time, but it's not going to make a whole lot of sense to us because that's a very abstract result. So I think it makes sense at this stage to put this in the calculator, and we're going to get a round-off answer. So I'm going to type that in the calculator. Now you need to be really careful with fractions. Use lots of parentheses. So I'm going to turn the calculator on and start typing in this outcome. Alright, so if you can see on the left side, I've got the calculator going. And log of 5, the numerator is just a single term. That's not a big problem. But if you have the older operating systems, you need to use a lot of parentheses. So I need to add parentheses around the bottom here. You can see these green parentheses. So when I type that in, I'm going to need a parenthesis around the bottom, and I'm going to type in the log. And also notice in the old operating system it starts the log, so the log has its own parenthesis to start it. 1.035. Now I'm closing the parenthesis on the log, minus, now I've got to subtract another log, and it's 1.016. Now the log started with a parenthesis here. I have to end that log, but now I started the bottom of the fraction way up at the top with the parenthesis, so I have to end another parenthesis. So if you have the old operating system, you've got to be really careful with how you type it. And when we do type it, we'll enter it, and we get that the time is approximately 86.86. Well, let's just call that 87 years. So in 87 years, this the city with the smaller population is going to catch up to the other city, B, that had the bigger initial population. Now, this method that we use to solve is consistent with the strategy that we've been using when we're solving exponential equations, and that we employed it right here. We did the log on both sides. Now, if you have an exponential, that's a pretty reliable strategy. In this case, it was a little bit involved. We had a lot of logs, we had a lot of algebra to keep track of, but it did give us a solution in the end. Now, like all algebra equations, there's not only one way. And some of you are more confident with your algebra skills, you're more sophisticated with log rules, and so you might have discovered a different way, or you might see a different approach to solving it, and that's okay to me. I don't mind how you solve your equations. But for those of you who are beginners, I am suggesting this basic strategy all the time until you get really good at it. And then you can start branching off and trying new strategies. But we did talk about this in class. There were a couple of people who tried it a different way, and they got the same result. And the different way does require a little bit of algebra insight, but it is faster. So I promised you I would re-record it and also show you the different way. So let's take a look at the other way we could solve this. All right, we've got the same equation presented to us again. We're going to have to get rid of the multiplication, so that part, same old, same old. We can undo multiplication with division. So we simplify to this equation, and that's exactly the same as we started off before. Now here's the new insight. The new insight requires an exponent law. If I have a to the t power and divide by b to the t power, it is the same as a over b. I can divide first and then do the power. Now I'm going to use this exponent law to help me solve this equation in a slightly easier way. Now that took some insight to realize, oh, I could do that. But I'm going to show you what it looks like here. I'm going to get all the t's on one side, and these cancel. Now notice I have a t power here and a t power here. It's the same power. So I can use this law here to rewrite this problem as 1.035 over 1.016. And I'm going to put the t power on the outside. And all of that equals 5. And now I only have one t exponent. And I want to get t by itself. Well, that's the same principle of solving an exponential, but we got to this point with a much tighter, smaller equation. I'm going to do a log on both sides. So I can do log on this side and log on the other side. And so this will be 5, and the input on the other side I'm going to fill in here by doing that log on both sides like this. So I took the black equation and I put the log on both sides of it. I have an exponent law, and I can take that exponent out. And once I've taken the exponent t out, I am very close to solving this guy. All I have to do is divide. Now the thing I have to divide by is this giant log, but I have to do it on both sides. Okay, so all of this divides out, and that leaves me t alone. So finally, I can come up here and give t as my final answer. T equals the log of 5 divided by log of 1.035 over 1.016. And that is my final answer for log. Now let's check that in the calculator and see if we get the same result. Alright, so I put the log of 5 in there. Now I'm going to divide. Now what's a little different this time is I'm dividing by only a single log. I just need this one log in the denominator. So when I come in here and type in log, I just need to type in one log. But the log is, inside of it is a division. 1.035 divided by 1.016. Now this closes the division. Okay, so I started the log and I have a division inside. And I have too many parentheses here. Okay, right up here there's too many parentheses, so I'm going to pause for a second. Alright, I realize it's not that big a deal. I'm just going to go up and back and hit the delete button. So the first log has a log of 5, then there's a division. Now I'm not worried about parentheses on the bottom because there's only one log. I don't have two logs in a subtraction on the bottom. I just have one log. And so this log opens up with this parenthesis here and ends with that parenthesis there, and I'm going to hit enter. And sure enough, we get the same 87 years. So it was two methods that solved the same problem. Both methods are legitimate. If you really understand this, feel free, if you come across this again in the future, to try something similar. But it did take a little bit of insight knowing about this exponent law here and seeing that, oh, we could use that. But anyways, I hope that was helpful. It was a lot cleaner and a lot smoother than class. I'm sorry, class, that was very jumbled and it was very messy. But anyways, hope this helps you study. So keep working hard on this stuff, and I'll see you in class. Oh no, no, don't stop. There is some more. There's another part to this lecture, so it's going to continue with the. I have a couple more examples after this one. So after this one, go ahead and see the next one in the list.